In this video, I will talk about mole fraction. What is mole fraction and why it is important. In general chemistry, we use the mole fraction in Raoult's law. But it is also an important concept since fraction, sort of fraction, might be very useful in your future education. So when you say fraction, it means that it changes between 0 to 1. So this is the meaning of the fraction. So a fraction cannot be bigger than 1 and cannot be smaller than 0. And consider a beaker, and we have 100 grams of ethanol, 100 grams of methanol, and 100 grams of, for instance, toluene. What is the molar mass of ethanol? We show the mole fraction by just this representation, which is X, this thing. But it is a little bit a fancy X. Maybe it has another different name, but we generally use this symbol to show the fraction. And mole of the everything, so we have to know the mole of every substance, not M, N. This is mole of methanol, and mole of toluene. If we want to calculate the mole fraction of the ethanol, then we need the mole fraction of the ethanol. So this is the basic idea. If I want to calculate the mole fraction of the methanol, then I need mole fraction of I need mole of the methanol plus total mole in the beaker. And similarly, if I want to calculate the mole fraction of toluene in the beaker, I need mole of toluene, so I have to calculate it, and all the moles of everything in the beaker. So basically we have toluene, we have methanol, and we have ethanol. So in here, all the molar masses of these compounds are different from each other. And to calculate it, we have to know the molar mass of each component, right? Since I have to calculate the mole number. And ethanol molar mass is 46.01 gram per mole. Methanol 32.04 gram per mole. Toluene 92.14 gram per mole. As you know, mole equals to mass over molar mass. So this is mass, which is 100 gram. For instance, for ethanol, I want to calculate ethanol, and we have 100 grams of ethanol, and molar mass of it 46.01 or 01. So this is 2.17 mole or moles. Similarly, we have to calculate the mole of methanol, 100 grams over 32.04 gram per mole, 3.12 moles. And I want to calculate the toluene, 100 grams over 92.14 gram per mole, which is 1.08 or 9. 9 is more correct. So if I want to calculate the molar fraction of one of these, for instance, I just calculate the one of them, methanol, it should be equal 3.12 moles over 2.17, which is the mass of the ethanol, plus 3.12, which is the methanol, and 1.09. So this is 6.38 3.12 over 6.38. So it is equal to 0.49. As you see, it is unitless. It is just a number between 0 and 1. By the way, if you want to check yourself, all the mole fractions, for instance, in our example, ethanol plus methanol plus toluene should be 1. This number should be 1. So for instance, I calculate methanol, which is 0.49, then I can say that molar fraction of ethanol plus toluene should be 0.51. 1 minus 0.49. I hope this video was useful. This was a simple video, and I hope you liked it.